Greetings to every one of you. In this video, we are going to discuss another important concept from operating system, that is necessary conditions for deadlock. Let me explain what deadlock is. Two or more processes unknowingly waiting for unavailable resources. Resources are there and all the resources are allocated to some other process, but without knowing that the processes are waiting for getting those resources is called deadlock. We have four conditions for deadlock. Let us see one by one. Mutual exclusion. Number 2, hold and wait. Number 3 is no preemption. The last one is circular wait. If all these conditions occur simultaneously, so there is a chance of getting the deadlock. It may result in deadlock. Let us see these conditions one by one. First of all, the mutual exclusion. A process can access only one resource at a time. So this means the process need resources. The resources are non-shareable. So one process can access only one resource at a time. It is possible. A resource can be accessed only by one process at a time. So many processes cannot access one particular resource at a time. So this is the concept of non-shareable. So no two processes can access a same resource at a time. So all the resources, as I said, are non-shareable. Example is a printer. If more than one process accessed the printer, it results in a corrupted output. That is what is called the interspersed output. See, let us consider a print process 1 is there, print process 2 is there, and both the processes are requesting the printer to print the outputs. So what will happen if simultaneously, if both the processes accessing the printer the same resource, so that will result in, that is, one portion of process 1 will be printed and another portion of process 2 will be printed, and that will result in a non-linear output. That is what is called interspersed output. So the mutual exclusion, it states that no two processes can access the same resource. So there is a possibility of getting deadlock. Number 2, holds and wait. Let us consider, I have given here a diagram in which we have two processes and two resources. The process 1 needs resource 2, so it requests resource 2. But the resource 2, it is already allocated to process 2. So what will happen? The process 2, it holds the resource, that is 2. Similarly, now the process 2 requests resource 1, but the process 1, it holds the resource 1. So P1 holds resource 1 and P2 holds resource 2. P1 is waiting for resource 2 and P2 is waiting for resource 1. So both these holds and wait. So it is P1 requesting resource 2, but resource 2, it is holds by process 2. So only if the process 2 release the resource 2, then only the process 1 can use this resource 2. Similarly, process 2, it needs resource 1, but the process 1 holds this resource 1. So because of that, P2, it is waiting. The process 2, it is waiting for resource 1, and similarly the process 1, it is waiting for the resource 2, but both are, that is, holds by mutually. Okay, so this condition, it is what is called the holds and weight condition. So even if this condition occurs, there is a chance of getting the deadlock. The third one is no preemption. The no preemption, it means the process holds the resource till its completion of the execution. It holds the resource, but it won't leave the resource in between. So till its completion, the resource will be occupied by the process. So that is what is called the no preemption. So even this being the case, the chance of getting deadlock is very much high. The fourth one is circular wait. We can take this example in which the process P1, it is waiting for resource 2, and process P2, it is waiting for resource 1. See that process 1, it is waiting for resource 2, but resource 2 is allocated to process 2. Now process 2, it is waiting for resource 1, but resource 1 is allocated to process 1. So this is a circular wait. See, for example, let us consider we have 4 processes and 4 resources. Process 1 requests resource 1, but resource 1 is allocated to process 2. Process 2 requests resource 2, but resource 2, it is allocated to process 3. Process 3 requesting resource 3, but resource 3, it is allocated to process 4, and process 4 requesting the resource 4, but resource 4 is allocated to process 1. So this is a condition called circular wait. Even this being the case, you will get the deadlock. All the 4 conditions occurred simultaneously, definitely it may result in deadlock. So in this video, we have discussed what is deadlock and what are the necessary conditions for deadlock: mutual exclusion, hold and wait, no preemption, and circular wait, and explain all these conditions with the examples and the suitable diagrams. I hope you understood the concept. So keep watching. Thank you.